So we're going to talk about 10.6 today. We're kind of switching order, and one reason why is because we got this EOC coming up, and we want to make sure that this is a section that we talk about before. We've seen it on the past on the EOC.
Well, and it's a formula that's on your formula sheet, so that's really where we're just making sure that you know your formulas.
Know it. And who knows, it may not be on there, but we just want to make sure that you have this exposure. The other reason why we can kind of flip it around is because it doesn't really depend on the other stuff. This section's kind of by itself, even though it's still dealing with circles. Now, notice the title of it is talking about the equations of circles. So back in Algebra 1, you talked about equations of lines or equations of a quadratic, okay? There was a certain form. Circles have a specific form of how to write the equation of it, okay? And the key here is you have to know certain things. Notice it says right here, it says you can write an equation of a circle in a coordinate plane if you know the following. You need to know the radius. And think about why you would need to know the radius of a circle.
Well, that tells you really how big to make your circle.
Exactly. It's going to give you that kind of restriction of how big or small. Now, we always use the r variable for radius, so we're going to keep using that. Now, the other thing we need to know to write the equation of a circle is the coordinates of the center. Now, why would you need to know the coordinates of the center?
Well, that seems like that would be logical too, because that would tell us how far from that from that center. Once I know the center point, I know where to start the circle, and then the radius will tell you how to extend it.
It kind of tells you where it's located in a sense, all right? Because that center point is also important. We have to know the center of a circle name-wise. Okay, that's how you name it. So the center, the coordinates. Now, they use variables h and k for the coordinates. Okay, so just kind of get comfortable with that. You'll see that when we explore the formula. All right, or the equation of a circle. All right, so Ms. Hochgrabe is going to have you do that for us.
Okay, so right now we can tell from here that we've got the coordinates of the center of the circle. It's h comma k, and they give us a point that's on the circle. Now, that can be helpful for us because it can help us define the what?
The radius.
The radius. So how would I find? I know the radius is talking about a segment, right? A length that goes from the center to any point that's on the circle.
And it doesn't matter which point. You just randomly, and I like that we just have x, y, because it could be any point.
So here's the thing. We want to be able to represent the radius. Okay?
Okay.
How could I, if I want to talk about the length of the radius?
Well, I'm thinking it's in a coordinate plane, and it's the distance between 2 points. We're going to use the distance formula.
Okay.
So let's call that r for, and once you label that in the picture, that's segment r. This is defining the radius. So the square root, and to find the distance between 2 points, you take the difference between the x values. So x minus h, because h is the x value of one of the points, squared, and then I add. And then I'm going to do the quantity y minus k squared. So I'm taking an x value minus an x value, squaring it, doing the same thing for the y's.
Right. Now, what's really cool is the formula for a circle comes from this idea of finding a radius.
So it's just kind of the distance formula in a sense.
The only thing is that we don't leave it as the radical and just saying r equals. We're going to say, if I wanted to get rid of the radical, what would I need to do?
I would have to square both sides.
So we're going to say r squared equals our x minus h, quantity squared, plus the y minus k, quantity squared. This right here is our equation of a circle.
That whole thing. Okay. So if you forget it, you can know where it comes from because we've used the distance formula so much, guys.
Oh, yes. And the nice thing, though, as you look in the formula, if you're trying to determine what the center is, notice the h and the k. They're next to the x and the y, but it's x minus the h and y minus the k. So just keep in mind, it's really the opposite of whatever number you see here because we're not going to be doing that subtraction part in that when I'm looking at the actual ordered pair.
All right, so the next slide is just kind of rewriting it again. All right, highlighting a couple pieces that Ms. Hochgrabe already said. Usually you see it written where the r squared comes second after the equal sign, but we know symmetric property allows you to go either way, okay? But most common, you'll see this stuff on the left and this on the right. Notice again, the r is your radius. Now, notice it's always going to be squared when you're dealing with the equation of a circle. And you can square a number. So you're not going to leave it as 2 squared. You're going to say, well, 2 squared is 4. Right? Now, the HK, again, stressing what Ms. Hochgrabe said, is that it's saying minus the H. So if you're thinking opposite, all right, minus whatever that h is, okay? So we'll do some examples in a minute. So this is your center, okay? Something to remember that the h, okay, alphabetical before k, h goes with x, k goes with y, alphabetical, kind of going along with that. Now, this kind of is this is more of a not real specific example, kind of generic, a little bit. It says, what would the equation be if the center is the origin? Now, all we know really is that the center is the origin. What is it that we don't know about
We don't know the radius.
And to find the equation of the circle, you need to know the radius. But if the center is the origin, now what's the coordinates of the origin?
0, 0.
So if I put 0 in for my h and k, so it would look like x minus
0, quantity squared, plus y minus 0, quantity squared, equals r squared.
And again, we would need to know this r to be more specific. Here's the deal. X minus 0 really is just x. So anything when the origin is 0 or 0, 0, or the center is origin, you're only going to see x squared plus y squared. That doesn't happen with every center point, okay?
Right.
This is just a specific kind of one, okay? So if you ever see 0 as one of the coordinates of your center, you don't really need to keep it in there, okay?
Okay.
Just a kind of heads up there. All right, let's get to more specific examples.
All right, so we're going to practice writing the equation of the circle given a center and given a radius, okay? So I know that I'm going to start with my x minus the x value of that center point.
Okay.
So x minus what in this case?
Well, that's my -5 is my h.
Right.
So it'd be minus a -5. So could I just put plus 5?
Absolutely. So x plus 5 quantity squared plus our y
minus 0 squared, and we'll talk about that in just a minute, equals, now it's my radius is 4.8, so 4.8 squared.
Love it. Now, this is not quite simplified.
Yes.
So we want to go ahead and simplify a little bit. We're not going to worry about trying to FOIL this out or anything.
So I wouldn't want to square the x and square the 5?
We couldn't do that anyways.
Exactly.
But we're going to leave it as just the x plus 5 quantity squared. But this one I could condense a little bit, because what do you know about y minus 0?
It would just be y squared.
And it's going to equal, what is 4.8 squared?
4.8 squared is 23.02, or 04, sorry.
So we're going to be able to simplify that radius squared. And if you notice you've got a 0 in there, you could go ahead and simplify.
So that would be the equation, that's it?
That's the equation of our circle.
Well, that seems easy enough.
It is. All right, next one.
Okay, so I'm going to do, okay, again, they give you the center and the radius. So the center is your kind of your HK in a sense, and the radius is your R. All right, so it's going to be x minus the x coordinate of that, so minus 2, quantity squared, plus y minus the 8 squared equals 7 squared, which would be 49.
And if you want to write this first and then write the simplified version, that's fine. Or if you want to go ahead and go straight to saying this 49, that would be fine.
We'd be okay with that, yeah.
All right.
Okay, now this one's a little bit different. I want you to read the directions first to kind of see what makes this one different.
Okay, it says we've got a point that is on the circle.
Okay, and they give you the point is
2, 1.
Okay.
And they give us the center of the circle. So there's our HK. So they don't give us the radius. I'm just noticing that. We're going to write the equation of the circle.
Okay.
But we can find the radius. If I have a point that's on the circle and I have the center, we know the radius is just the distance between that point that's on the circle, any point on the circle, and the center of the circle.
Okay, I want to make a little kind of summarize what we're saying here. To write the equation of a circle, again, we need to know the radius and we need to know the center. Now, you're telling me we already have this, but this is our question mark.
Right.
So if we can find this, find the radius, then we can write the equation. Okay. Now, you said the distance between a point that's on the circle, this is a point that's on the circle, and the center is essentially the radius.
Right.
So we're going to find the distance between this point, and that will be the radius. Okay, so we're going to do that. So my radius equals, and how are you going to find the distance?
I'm going to have to use the distance formula. So the square root of, we've got our 2 minus 4 quantity squared, and our 1, or plus, sorry, a 1, and it's going to be minus a -3, so 1 plus 3 quantity squared.
A little delay there. I'm sorry. I was like, woo. All right. So the radius equals, and we've used the distance formula a lot, guys.
Yeah. So negative 2 squared will be a 4. And that 4 squared will be a 16.
So the radius is the square root of
20.
Okay. Now, here's the deal. Do we need to simplify that radical?
Tell you what, let's not worry about it yet. Let's see if we need to.
Okay.
How about that?
Okay. And then here's the deal. Don't put it in your calculator and get around an answer either.
No.
All right? So here's the deal. We need to write the equation of a circle. You said we need to know the center. That's your HK. We need to know the radius. We just found it. So how do you write the equation?
So we're going to take x minus, and the x value was our, for the center, was our 4.
Yeah, and again, this 2, 1
was just
is
to help us
nothing.
define
We
the
don't need
radius.
that now. We don't need that anymore. This is what we need, okay? So if you need to, so the radius is radical 20. Our center is 4, negative 3. These are the only 2 things we really need now. All right, so x minus 4, that quantity squared.
Plus, and then we're going to take y, again, it would be minus a negative 3, so plus 3. Quantity squared. Now, it equals our r squared. So r was radical 20, but when I square a radical 20, I just get 20.
So what I'm doing, I'm going to kind of write over here. So this is, we're taking this, we're trying to get r squared. So to get r squared, we've got to square that. So what's my r squared going to be?
R squared is just going to be 20. So the nice thing, once you find your radius, if it is a radical, just leave it as that radical, because in the equation, it's not just r, it's r squared. So we're going to be getting rid of that radical sign.
Now, a couple of things that I want to point out. One thing that I've seen in the past is that people will want to use this 2, 1 and put it in here and here. Your equation of a circle will have x and y in it.
Right,
okay?
because that x and y represents any point on the circle.
Okay. The other comment I want to make is the fact that technically to write the equation of a circle, we need to know, yes, the radius, but whatever the radius is squared. So if you think about when you're using the distance formula, instead of saying r equals, you could say r squared, and instead of having the square root, you could have all of this stuff. Okay, that's just another option, all right? I know that not many always think about that, but it allows you to get right, because then you would just have, say, r squared equals 20, and then you're going to put it in for that r squared. The common mistake is that people use that 20 and want to square that again.
Right.
So just be cautious. Just an option for those that want to kind of do it a little bit differently.
Okay. All right, the next one says that we're going to graph the circle.
Okay.
Okay, so if we were going to graph this on a coordinate plane.
Which we need graph paper to graph, guys, okay?
Yes.
Stressing that.
So what are the things that we know, and from our equation of a circle, what does it give us?
Well, the equation of a circle tells us the radius.
So what is our radius here?
Well, the r squared is the 9. So to get the r, you're going to take the square root. Now, we know with a quadratic, r could be plus or minus, but you can't have a negative distance. So r is just 3.
Right. Love it. And then what else are we given from our equation of our circle?
Center, because the equation tells you those 2 things, radius and center. So the center, okay, here's where you got to be careful. It is, remember, x minus h. So since it says plus 2, it's going to be the opposite of that, so it'd be negative 2. And then since it says y minus k, that's going to be just a positive 3.
So it's really the opposite of whatever numbers you see in here, because we know it was x minus and then some x value. So that x value had to be a negative in order to make this then a positive.
Perfect.
Okay. Now, when you plot this, what I want you guys to start by doing is go ahead and plot the center point first.
Okay.
Because obviously you can't measure a distance if you don't know where to start it from.
Got to have where it's located. So let's do that. So left 2 and up 3.
So there's my center. Now, I can count 3 units.
Anywhere, right?
Anywhere, except for some places it's going to be really hard to count exactly 3 units.
Okay.
But I know I can count 3 units vertically
horizontally.
and horizontally. So I'm going to go up 1, 2, 3. That represents a radius of 3. I'm going to go down 1, 2, 3. That represents a radius of 3. And I'm going to go to the sides 1, 2, 3. And I should start to see kind of the boundaries of where my circle's going to be.
And those
placed.
are actually going to be points that are on that circle, right?
Those are points that are on the circle.
Yes.
All right, but I want you guys to realize these are kind of the boundaries of making your circle. Now, I don't expect your circles to be super beautiful. I'm going to totally cheat here, actually, because I know how bad my circles are when I've done them in the past. But just to give you guys an idea that you should be able to draw a kind of an idea of a circle from those boundaries.
Now, guys, the one thing we don't want you to see is like a square or a rhombus looking shape.
Yeah.
So when you do draw it,
like if I was to sketch this by freehand, I'll show you guys how bad it's going to be.
Hey, that's not bad.
Oh, it started off better than it ended
It's not
up.
bad. But guys,
yeah.
we're not going to be picky, but it needs to resemble looking like a circle.
Right.
Okay?
Okay.
All right. This one we want you guys to try on your own, okay? So get practice. Think about if they give you the equation of a circle and they ask you to graph it, right? What does it tell you? Go ahead and do that and check with us. All right. So what does the equation of a circle tell us, Ms. O'Grady?
It tells us the radius and it tells us the center.
All right. So let's figure out what the radius is.
Okay, so keep in mind that 4 is our r squared. So when I square root the 4, I'm going to get just r is 2.
Okay, so keep that in mind. Now, what's the center?
The center should be 3, -1.
Again, opposite of this, opposite of that. All right, so where should we start?
We started our center at 3, -1, and then our radius is 2, so we're going to go 2 units in each direction.
And again, diagonally would be harder to do. 2 units diagonally is happening, it's just harder to graph it that way. We're going to try to pick it as easy as possible. Now, again, don't make it look like this. Don't just like connect them and make it look like a square or a rhombus or whatever, okay? So when you graph it, if I can speak. Oop. I'm going to start over. It's harder to do.
Yeah. Oh, that's a pretty good
Not
looking
too bad.
circle. Actually, that's a pretty good looking
So
circle.
here's the deal. When you see a question like this, we are going to be looking for, did they have the right radius and do they have the right center? All right. And obviously, does it resemble a circle? Okay.
Okay. Next one, it says the equation of a circle is, and they've given us another equation. And since the fact that they're giving us a graph, it looks like we could choose to graph this.
Okay.
But it also then says, where is each point located? Is it inside, outside, or on the circle? Now, I'm going to go ahead and graph this with you because I want you to get this visual. But you don't really need to graph this one. They don't require you to graph.
So we'll show you another way of doing this too.
Yes. All right. What is the 2 things that we know from this?
Radius is 3, and the center is 7, 6.
All right, so let's go ahead and let's graph this circle. All right, so here we go. 7, 6. There's my center. And the radius is 3, so up 1, 2, 3 space. Oh, did I just count 4?
Yeah.
Yep, I did.
Now, while she's doing this, guys, keep in mind that it doesn't say to graph. There's going to be a question like, or something like this on your classwork, and this option is more of a visual option. The thing about this one is if you're not great about graphing the circle, it may not be your best option,
Right.
okay? And I'll be honest, I don't prefer doing the graphing method because, again, if there's another way of doing it, graphing sometimes takes some time, okay?
Right.
So we'll talk about another option here in a little bit, okay?
Yes. All right. So if I look at point A, which is at 5, 6, 5, 6, that clearly, that point A is where?
Inside.
And B was at 4, 7. That one's a little harder to tell.
To me, it looks like it could be outside. It's pretty close to that circle. So I'm going to put outside. Can I put question mark?
Yes.
Just because I'm not really sure about that one.
Okay. What about point C?
310. So that's clearly outside.
And 7, 3.
To me, I'm guessing, I'm not going to guess, but to me it looks like it's on.
Yeah. In fact, that is the point where we drew our point for our radius.
Will you label
too.
that point real quick?
Yes.
Okay.
All right. Now, we know that there is another method. So let's
Okay.
talk about that other method.
Okay. All right, let's start with point A. Now, again, if you don't want to graph it, this is an option. That 5, 6 represents an X and a Y. All right? So I'm going to substitute 5 and 6 into my equation. All right? So I'm going to put quantity 5 minus 7 squared plus 6 minus 6, that quantity squared. And I'm going to put, does it equal 9? Now, here's the deal. We don't know if it's going to equal 9. If it does, then what would that mean?
then that would mean that it's on the circle.
Okay. Now, if it's not, then we'll talk about how do we know.
Okay.
So let's go ahead and answer that. So that's going to be negative 2 squared is 4. And that's going to be plus 0. Okay, so that means 4 is not. So 4 is actually, I'm going to put less than 9. And here's what I'm noticing. Because we know it's clearly inside. If that all that stuff on the left side ends up being less than the radius squared, then that's going to be inside.
Okay.
Okay. So let's check point B, because point B was the one that was kind of a little sketchy.
Questionable.
So I'm going to do 4 minus 7, that quantity squared, plus 7 minus 6 quantity squared. And we're going to put, does it equal 9? All right, so that's going to be a negative 3 squared, 9, plus 1 squared, 1. That is 10, and that's obviously not equal to, so it's greater than. That has to be outside since it's greater than.
And another way to think about that one too, if I know it's exactly 3 units from the center, looking at the graph, 3 units from the center is clearly here. But if I start moving up, notice that if I drew in a little right triangle, that would be the hypotenuse. That would have to be longer than the 3. So kind of another way to reason that one too. Okay, great.
So, and here's the other one, C, we saw is clearly outside. The on, what's going to happen is they're going to be exactly 9 when you substitute that in. So do you want to do that?
Let's show them real quick.
Okay, so 7 minus 7, that quantity squared, plus 3 minus 6, that quantity squared.
Sorry.
And we're going to see, does it equal 9? So that's going to be 0, nothing. This can be 9 is 9. So that's exactly on.
Awesome.